All right, here is FRQ2 from topic 213, which is back from February 7th, as promised. Now, this FRQ is very, very similar to the actual FRQ2 on the exam last year, up to where even this natural log of t plus 1. Now, FRQ2 in general isn't necessarily logarithmic. It could be exponential, it could be linear, quadratic, cubic, it could be a lot of things, but last year it was logarithmic and we still need to know how to do it. So one of the things we did talk about quickly today in class to make sure everybody could just go ahead and get this started because it was a big question was this percentage thing. So let's read through this. It says in May 2011, t equals 0, 65% of US adults did not own a smartphone. In November 2016, t equals 5.5. Only 23% of US adults did not own a smartphone. Now, traditionally, and probably every time you've ever dealt with percentages, you have changed them to decimals such as 0.65 or 0.23. But we are like, so if I needed 65% of something, I'm going to multiply it by 0.65. But let's keep reading. It says the percent of US adults that did not own a smartphone can be modeled by function S, given by this right here, where S of t is the percent. Okay, so S of t is the percent. So I'm not using 0.65, I'm going to use 65. The 65% and 23% are not being used as calculations in this function, so I'm actually using the 65 and 23, which tells me my ordered pairs here are 0, 65, and 5.5, 23. And for this particular function, that represents t S of t. Okay. So the first part of this says to use the given data to write two equations that can be used to find A and B. All right, so I'm looking at this and these two ordered pairs. So my S of t, which for the first one is 65, that's equal to A plus B, which I don't know, times the natural log of t, which is 0, plus 1. Then I write the next one, S of t, which will be 23. Maybe I should move over just a little bit. 23 equals A plus B, which I don't know, times the natural log of 5.5 plus 1. I wrote them. That's all I do. Do not miss this first part on this one, on the test that you're about to take, on the FRQ, on the actual exam, or any of the other ones. Write them and stop. Now I want to find the values of A and B. I could do that by hand, but I don't need to. I have my calculator, or I have Desmos. So I'm going to go in here, and I'm going to add my table, and my points, my X values are 0 and 5.5. And my Y values are 60. Sorry, I'm looking at something. Oh, shoot. Oh, yeah. They are, 65 and 23. I had that right. 65 and 23. Alrighty, so I'm going to zoom. I'm going to do my regression. I know this is supposed to be logarithmic, and I get the error, right? Which is not a big shock to me. Remember, if you get the error and you're like, what the heck, we can do this. Well, we know that not only the regressions, but logs in general, you can only take the log if it is a positive number. So I have this 0 in here that's causing the problem. Remember, over here, it's not really a problem because really it's 0 plus 1. So we did a couple of different things with our logarithmic regression. We either manipulated the regression, which I can't do because I can't even export it because I don't even have one, or we manipulated our X values, but we did not do both. And so because the only thing this is going to give me, it's not going to give me a t plus 1 or x plus 1. It's A plus B times the natural log of x. That's the only thing it's going to spit out for me. So since this was t plus 1, I'm going to go in here and I'm going to add 1 to each of my X values. So when I do that, that becomes 1, and then this becomes 6.5, okay? So now I have an actual answer. I look for a log mode button. There isn't one, so I don't have to worry about that. Now it gives me this equation here. And I know that I want my equation to look like this with the t plus 1. That's not what I'm seeing there. But what I used was t plus 1. I basically just took care of that for it. And so let me explain one more time about the manipulating the regression versus manipulating the x values. So I'm going to export this, but I'm not going to actually do anything. So one of the things we did do is we exported the regression, and then we went in here and we adjusted, like we changed natural log to log base 3, or we changed something else. But if I change anything in here, it's going to change these numbers. Like it's actually going to change the calculation, the regression itself. I don't want that to happen, okay? I want what it gives me when I manipulate the x values, it gives me the numbers that I want. So right now I can answer my A and B. Even though this doesn't say +1, we took care of it up here. This is my A and B, so I can answer that question. Then we're going to go back and talk about that a little bit more. A is 65, and B is negative 22.43827. Right? Now, what I'm going to need to move forward and do more with this. So what I want is my graph to be accurate. My graph is not accurate according to these ordered pairs, like 0, 65. If I look at 0, I'm not at 0, 65. 0 is like up here somewhere. But I should have a point going through 0, 65, and I don't. So I'm not manipulating my regression, and I'm not going to export that. Right above where it says equation right here, I'm going to click that, and it spits the equation out for me. When I manipulate this, the numbers don't change unless I change them, because it's literally just the equation. So if I move this over and I change this now to +1, like I know what it's supposed to be, you see my blue curve here, I do have this point 0, 65. This says 165, but that's because it's 0 plus 1, right? Because the t plus 1. This is my real equation right here. So if I'm going to do anything else on the graph, I don't want the black one, so I'm going to turn it off so I don't get confused, and I can turn off the green points. So that's the function that I would actually use to do the things I need to do. All right, so let's come back over here and see what the next part says. This says we're going to use the given data to find the average rate of change, which we know is just slope, in the percent of US adults, excuse me, that did not own a smartphone in percent per year from 0 to 5.5. So I've told you many times I like to go ahead and write this out as my little interval. And it says to express your answer as a decimal approximation. So we can do slope. And I'm going to do it first with the correct variables and whatnot in function notation. My function is s of t, right? Yes, s of t. So that means I want s of 5.5 minus s of 0 over 5.5 minus 0. You have to write that step. It's going to help you on the next part. So then I substitute in what I know. S of 5.5 is 23 minus 65 over 5.5. Okay, and I'm going to let the calculator do all of the rest. Not only that, but I'm going to show you something else on the calculator here. Now we know we can let the calculator do everything. But remember, like these numbers for A and B, I can't store them anywhere. We don't have that ability yet in Desmos. I don't know if we ever will. But there's sort of a way to store numbers really just by labeling them. So yes, I'm going to find this. Now remember, this is slope. Slope is m. So here, before I type in my actual numbers, I'm going to say m equals, and then I'm going to do it. And that was 23. No, let me make sure I do them in the right order. Yeah, 23 minus 65. 23 minus 65 over 5.5. Okay, now I would have gotten this number right here, regardless of whether or not I put the m in there. And then I'm going to write down 5 decimal places, so let's just go ahead and do that. That's equal to negative 7.63636. Now remember, we write down 5 decimal places in case we have to type something back in. I could also, especially since it's highlighted, I could copy and paste this number. But look, I've identified it as m. Let me put a few of these so I can scroll. So if I can use, since I've called it m, I can use m right here. If I just click m, you see how it is that number? I've identified it. So now I don't have to copy and paste. I don't have to do anything. It's there. So it's kind of a way to store numbers. We just can't always store all the numbers. So that's going to help us on the next part. Okay. I have my rate of change. I've expressed it as a decimal approximation. I've shown my computations, right? Now it says to use the average rate of change from this part here to estimate the percent of US that did not own a smartphone for T equals 10.2 years. Okay, so let me explain to you again what we're actually doing here. Now you can look at the graph and see, okay, I know what's happening with my curve. My curve looks like this, right? And I'm being a little bit more dramatic so that you can kind of read this a little bit better. We just found the slope of this line, this being at 0, this being at 5.5. And like on my x-axis, like this would be at 0, this would be at 5.5. So it's saying to use that red line, the slope of this red line, to estimate this. Okay, now yes, I know I could actually find it on my curve. That's not what it's asking me to do. Let's pretend like this is 10.2. This would be my actual value. My estimation would be down here. And again, my picture's a little bit dramatic, so it looks way, way off. But I'm going to get the number from my line using the slope, and it's going to be an underestimate. And I can see that because it's below the curve. So when I do that and I'm using the average rate of change, remember I told you, we could write equations of lines, but it's so much easier to just use the slope. And if you have it written out like this, you're going to be fine. You also have options as to which one of these you replace. My suggestion to make your life easier is to replace the first one. So I'm going to estimate what S of 10.2 is. And I'm just going to replace that in this slope formula. And then I'm going to say S of 10.2 minus S of 0 over 10.2 minus 0. And it's telling me to use this slope. So if I'm now looking for this point, I use these 2 points to find the slope. It's still going to be the same slope. And if I say, oh, I said this was equal to M in Desmos, so I can say that this is equal, well, I'll do that in just a second. Let's fill in what we know. Let's see, S of 10.2, I don't know because that's what I'm going to estimate. Minus S of 0 is 65 over 10.2. So I can say equals, and I could write that down, that decimal, but I can also just say equals M. All right, so then I'm going to look for that. When I do that, and I could write all this stuff out, but you don't need to. If I'm trying to get S of 10.2, I'm going to take M, multiply it by 10.2, and add 65. So I'm literally going to use M over here. And I'm going to say M times 10.2. And then I'm going to add 65. Right? So I get that number right there. So what that is, I just solved for S of 10.2. So that means that S of 10.2, and it told me to estimate it. I'm going to say that is about negative, nope, it's not, I'm about to write. Negative 12.89090. And if you think about what that means, that is the percent of US adults that don't own a smartphone, or don't own a smartphone. And a negative number doesn't make sense for that, but that's because our estimation is way off. Okay, so we're not going to overanalyze that. Now this next part here says, and this is very wordy, so we got to make sure we can make sense of all this. Consider the values that result from using the average rate of change found in N1 to estimate the percent of US adults that do not own a smartphone. So it's saying, let's think about, if I'm going to use this slope and I'm going to use it to estimate numbers, right? Consider the values that result from using that for T equals P, where P is greater than 6. So remember, we got this going from 0 to 5.5. So when P is greater than 6, are these estimates less than or greater than the percent of US adults that don't own a smartphone at time T equals P years? So from this little picture we have here, I can see that if this is my curve, right, and these were my estimates, or this was my estimate, clearly the estimate is less. Now, I can't say it's less because it looks less or because it doesn't give me the same thing or whatever. I have to explain it better. It says to explain your reasoning, and your explanation should include a reference to the graph of S and characteristics of the average rate of change. So when we were talking about the graph and the average rate of change, we need our fun chart. Okay. And this function that I can see on my graph over there, plus I made a really bad sketch here, it is concave up. So the rate of change is increasing. And the function is also, the function itself is decreasing. Oh, I'm doing the wrong thing. Since the function is decreasing, the rate of change is negative. So we can talk about the line being below the graph, but we have to do it in such a way that we're talking about the graph. The line that intersects a function at 2 points is called the secant line. Now, if you can't come up with the word secant when you're doing it, you can say the line that intersects the function at 2 points. Like, that's totally fine. Okay, but let's try and answer our question here. So it's asking me the values that result from using the average rate of change in part 1. When I use that, is it going to be less than or greater than basically the actual values? So I will say the values from using average rate of change from 1 will be less than actual values of S. Okay, so I can say that, but then I'm going to have to say why. And it's not always, right? They're not always going to be less. Here it will be more. So I have to say where, or when, whatever, when P is greater than 6. Then I have to say why, okay? So I can say that S is concave up and decreasing. Therefore, secant line from 1 is above the graph. Okay, I'm running out of room. I know I am, so I'm going to jump like down here so I can put my C right there. Is above S on, what did we go to? We went from 0 to 5.5. 0 to 5.5. And below graph, when P is greater than 5.5. Okay, we could put 6 because that's what it said in there. Now, here's one thing that's kind of weird about this particular question is I don't really need to talk about the characteristics of the average rate of change, but it says I do. So I need to go ahead. I know what's happening with the rates of change. I just figured that out. Rate of change is increasing and negative. So I can then just go ahead and say, well, I should say average. Average rates of change are negative and increasing. And that's true for the whole thing because it's always concave up. Now, before you start to freak out about this explanation and this being all weird, okay? That whole explanation, that is worth 1 point. 1 of 6 points on an FRQ. Are you going to get all 6 points on every FRQ? Chances are pretty good that you won't, and that's okay. That's how the test is built. If we can get it at the very least 2 points, hopefully 3 or 4, we are rocking it. So if there's like little tiny parts of these FRQs that you're like, what? Let's focus on the rest and you'll be okay, right? Not that big of a deal. All right, so now it says Model S is a valid model to estimate, so it is a valid, so it's telling me, not asking me. Valid model to estimate the percent of US adults that do not own a smartphone as long as the predicted percent is greater than 0. Predicted percent. That is my output. As long as my output or my Y value is greater than 0. And that makes sense, right? Because you can't have that negative percent of people, doesn't really make any sense. Explain how this information can be used to determine the domain limitations for the Model S. So let's figure out the domain. My input is time. So time can't be negative. So I got to start at 0. But time can be 0 because we already have that on there. So my domain, so I'm just going to say domain of S is, right, and I'm going to go from 0, which I get to include, to, now let's go back over here and look. I can keep going as far as input, time goes on, so I can do whatever, but it doesn't make sense once my percentages start getting negative. So I need to figure out this y-intercept, or the x-intercept right there. And I think you know that if you tap that and the point comes up, but sometimes when I go over to the left and the point disappears, this little thing right here, if I do that, then the point's over there. I don't have to like go back and re-click or whatever. So that's when it becomes, when the percentages become 0. And it says here, now to me, I think percentages could be 0, but this says percent is greater than 0. It does not say greater than or equal to. So I'm going from 0 to 17.11674. Okay, that is my domain. I could have written the domain. You don't have to write it twice, but you could. Oh, I totally just closed that when I said I can't include it. You don't have to write it twice, but you could have written it like this. I like interval notation better, but that is the domain, okay? So we use that because when S of t equals 0, when t equals 17.11674, okay? And then we can say after that, the percentages are negative. So even though like the part right above this that I wrote in green, that might kind of blow your mind, and that is very wordy, and that part of the question can be asked multiple, different ways. Don't let that cloud your vision where you can't figure out something like domain, like in the last part. Okay, there you go.